All right, in this video, I want you to focus on our limit rule number 5. Our limit rule number 5 says that if we have a polynomial, right, what we should be able to do when we apply the limit is simply take the limit as x approaches a certain value, a, of our polynomial, p of x, and we can evaluate it by taking whatever that number is and substituting it in for x. Really, we're just direct substitution. We're just plugging that value in. So I should be able to give you any function, for example, number 5, and ask you to evaluate the limit. So even if we don't know the answers, like we did in the last problem and we used our limit rules, even if we don't know the answer to our limit, we should still be able to find the limit by doing direct substitution. So in example number 5a, it says find the limit as x approaches 5, and then we have this polynomial 2x squared minus 3x plus 4. All we really have to do is take that 5 and substitute it in wherever we see an x. We want to figure out what's happening as x equals 5. If I substitute in a 5 and I simplify, 5 squared is 25, 25 times 2 is 50, 3 times 5 is 15, and then I have plus 4. After simplifying, I ended up getting the limit as x approaches 5 of my function, 2x squared minus 3x plus 4, is equal to 39. You notice that I used really good notation here, that I don't just have a floating 39 on my paper, that I've used the notation, the limit as x approaches 5 of my function equals 39. That's what I'm expecting you to do as you're working through your homework and as you're doing your exams, so that you can practice all of that good notation. You don't just have floating numbers on your paper. Okay? Let's do another one. The limit as x approaches 3 of this function. Now, this isn't just a polynomial, it's a rational function, but we can still use the direct substitution idea, where we can take that 3, substitute it in for every variable in our problem, in the numerator and in the denominator. So if I plug in 3 to the top and 3 to the bottom, it looks like this. 3 squared is 9, minus 4 is 5. 3 plus 1 is 4, the square root of 4 is 2. So I can say that the limit as x approaches 3 of my function is equal to 5/2. What that means is if we were following the path and you were coming up to the path from the left and I was following the path from the right, as we approach x equals 3, we're going to be together at 5/2. Just like on A, if we approached x equals 5 together, you were coming from the left and I was coming from the right, where would we meet up? Well, we would meet up at 39. We can follow the path and meet up together at those two values. We didn't have to worry about holes. We didn't have to worry about vertical asymptotes. We can figure out what our limit is by doing direct substitution. We'll talk in the next video about what happens when we do direct substitution and we end up hitting a hole or a vertical asymptote.